In this video, I will show you how to build a Dash web app just like the one on the right that lets you upload a CSV file and then chat with it using the OpenAI API. Starting at the top in VS Code, I import Dash, pandas, the OpenAI client, and a handful of other libraries that will help me handle file reading and parsing. I then bring in my .env file with load.env. My env file contains my key to my project and account I created on OpenAI prior to making this video. You can easily acquire your own at openai.com. I don't need to do anything more with the key. When it's loaded into the environment, the OpenAI client, which I create on the next line, reads it and authenticates me. I next create the app with the call to the Dash object. Next, I have the layout of the page. I won't go too into detail on this. I want to focus on the AI implementation. So let's go through this very quickly for a brief overview. We have a single div that contains some text up top and an upload object. Under, we have a section for previewing the data you uploaded and prompting for a question. Finally, you have a button to ask your question and an output for the chat's response. One thing I do want to stop and touch on are these two store objects. They can help you create a history of conversation in Dash. One store will house our data. The other will be the conversation the AI model and I have over time. After the layout, we have the callbacks. Here's where the chat functionality lives. This first one is straightforward. It's the data table preview that's shown right here. It reads in the content of the data uploaded. Since nothing has been uploaded yet, we see the placeholder "No file uploaded yet." It then takes the data in, which we can see is occurring with the input of our callback up here, and splits the content. This split returns the type of the content and the actual content, which is represented as a string. The string content is then decoded with the B64 decode function, which allows pandas to read it. This decoded object is passed to the read CSV function of pandas. You have to wrap the decoded object with string IO, as that's the type of object pandas is expecting. Basically, this section turns the uploaded CSV into a data frame. Next, we create a rudimentary Dash table and show only 5 rows of data by passing 5 to the head method of the data frame. Finally, we convert the data into a JSON object and save it in a store object for the chat to read. In this second callback, we have the actual chat integration. Let's go through and explain what's happening and why all pieces are needed. First, we read in the data frame from memory, which was stored in the previous callback. Next, we have a variable called context. This steers the model's behavior. It should act like a careful data analyst and not hallucinate beyond the table provided. Here you can see I'm sending the data as a markdown because the model expects the CSV data in a structured, readable way. In this demo, I'm passing the entire table because it's fairly small and I just want to show functionality. For your purpose, you may want to scale the model or select a subset of data. You'll also have to consider which kind of model you'll want to use and how it'll respond to the size of the data. I am also, of course, including the question to go along with this data. This context variable is going to serve as the content we provide our model per question we ask. We next have a list contained in the messages variable. The model uses this list as a conversation history to generate its answer. The only item of the list is the system's content, which provides a high-level directive that biases the model to, for our purpose, focus on the table. The items that we will be adding to this list in this callback are the discussion history of the chat. Here I am checking if a history of the conversation exists. If it does, I attach the entire history of the conversation of the messages. This provides the additional content to keep the conversation going. I then add the latest question by appending the context of the current question to the history of messages. Now on to sending the message to the API. To the model argument, we're sending GPT-4o Mini because it's a lightweight and fast option to answer table questions, perfect for a quick demo. The best model for you will be found with some testing, but there are dozens of options available to you. They can be seen and evaluated on OpenAI's site. To the messages argument, we send the messages we created. This is the content of the entire chat that AI will review to provide us an answer. I set max token as 500 as a cap on how long we want our answer. We store the response from the API in the response variable. Now to extract the message from the response. That's done by using the choices attribute of the response and selecting the first of the list. That object has a message, which is a content attribute. That content attribute is the actual answer string of text. We return that string of text in the answer variable. With this new answer, we have additional information for our history of messages. I have this new history variable that stores either the entire history of the conversation thus far or a blank list if a history does not yet exist. I then add the most recently generated AI answer. I'm adding the context that I, the user, sent to the API. I am also storing the API-generated answer in the assistant role. This is important. The assistant role alerts the API that what is stored in the content is something the API itself generated. It's not something that the user generated. That lets it keep continuity. It can refer back to what it previously concluded, where it corrects itself, and how to avoid contradicting itself. Finally, I add the standard block to run the Dash development server. Moving to the browser now, let's load in the data. I'll drag over this test file called fake data. Below we see populated the first 5 rows, as expected. This is all fake data related to sales of salespeople from different regions, so there might be some weirdness to it, but the actual numbers and amounts don't matter. It's purely here for demo purposes. Now let's bring over a question. Please give me an analysis of what products sold the most, which region was the best performing, and what month was the most and least profitable. Very nice, we have received an answer. Based on the data and our question, we see the most products sold are the standing desk, the best performing region is the South region, and the most and least profitable months are listed below. Since we set a limit to how long we wanted our response, we don't see everything, but no matter. What we'll focus on is the South region as the most profitable region. Now I'll ask my CSV another question. Since it already knows the South region is the most profitable, I want to elaborate on that without specifying which region I'm talking about. I'll ask it to tell me more about the best performing region. Let's hit Ask, and behind the scenes, it will review the answer it already provided for the first question and use that conversation history to elaborate on my new question. There we go, we have our second answer. We see the callout at the top for the South region and are provided some more information about it, such as product sold, best salespeople, and so on. You can continue in this vein, conversing back and forth with your CSV as you mine deeper into your dataset and extract more insights. So in the end, it's pretty easy. You create a layout you like with Dash. You have a callback that collects and stores the data for your chatbot to ingest. Then you have a callback that delivers to the API the needed information to have a conversation. This includes making some context for the question, creating a conversation history of messages, sending the content to the API, and extracting the answer, which gets displayed on the layout. Thank you for watching. Please let me know in the comments if this was a helpful video. Do give it a thumbs up if you liked it, and don't forget to subscribe so you know when the next video drops.